times, but the chance that you'll go above and beyond the login program is actually very, very minimal, right? It's almost impossible for you to guess the password and username and password and go beyond your program, right? Unless you have a really lousy authentication protocol. Otherwise, pretty much for any practical algorithm for authentication, logins, you're not going to go beyond that. Right? For instance, if you're just going to try Google Gmail, and hopefully you can get into Gmail by randomly trying the username and password, I think the chance you will get in is very, very minimal. Very, very minimal. Right? That is essentially to say, hey, you're doing random testing, your efficiency and your effectiveness wouldn't be too good. So essentially, we need a systematic way to construct test cases. So we pick and choose test cases we need to run. All right. So essentially there are two extremes to testing. First one is test to specification, also called to test to black box, data-driven, function-driven input-output testing. Basic here say I don't care about your code. Okay, I'm testing your code, but I'm not going to take your code into consideration when I come out with test cases. Okay, so this is essentially your customer-driven customer acceptance test, and so that is a good example. Your customer cares nothing about your code. Your customer just wants a good, easy-to-use app that does the job. Okay, so essentially in there you basically say, oh, forget about your code. The code exists. That's what we are trying to test, but we're not going to take your code into consideration. We're not. So basically, we are just coming up with test cases which will access your code from your interface. Okay, that's why it's called a black box. Okay, you look at this. Really, this is a black box, right? You're not looking into the implementation and say what kind of language is using, what kind of microprocessor is using, what kind of how much code it have in there and so forth. You're basically just going to test from outside, right? You're not opening up the box. So that is test to specification, input-output test, and only from outside. Or you can test to code, which is essentially called white box testing. So you look into the code and say, okay, what branches you have, let's cover them all. What functionality you have, let's cover them all. Basically, you test the code to test the code, right? You look at what your code have and test to that, right? So in this case, you may say, oh, I just going to test the code. I don't even look at your specification. I'm just going to look at your code. That is also can be fairly effective. For instance, when you test the code to have whether it have buffer overflow, whether it have divided by 0 and so forth, that kind of thing, you don't really need a specification, right? You don't need a functional specification. You just need to have the code to see whether your code is going to fail or not. Okay, those are two extremes. But the reality is you do both. Okay, you have to do both. One is not going to be sufficient. All right. So the reality is you do both, but you cannot exhaustively do both either, right? First of all, your specification can be fairly. So basically, if you only test those specification, you only look at outside the system. You only look at possible input, but typically your possible input is going to be huge. If you have something say, oh, I'm going to handle 1,000 signals, each one have binary input, okay? To try out all the possible combination, it's impossible. All right. So, but how long does it take for you to write a program that have 1,000 Boolean variable input? A minute. Okay? So if I'm going to so basically if somebody give you oh, I have a magic testing system that you can use and just enumerate all your input, you can laugh at him right away because you can easily write a program which have 10,000 Boolean variable input, and there's no way they can enumerate them all, right? So essentially, if you look at all these combinations, basically this is why we study mathematics, probabilities in our discipline. Because this will give you the foundation. when you think about that, if somebody say, hey, why don't you go test the program, enumerate 2 to the power of 1,000, you will say, oh, mathematically that's impossible to do with the practical resources, right? That is exactly why you're going to look at this and say, hey, what is feasibility of testing to the specification? If the input and output combination is too great, you cannot do them all. You have to pick and choose. That's another thing that we are not doing in our quiz. We are doing a little bit, but not too much. Is not only you have to come up with an algorithm, but you also have to come up with an algorithm which satisfy your memory and time requirements. Basically, those things will be in a big O format, right? Say, okay, on order of what? On order of n, or on order of n squared, or order of n, times log n, or so basically, what's the time complexity and storage memory complexity of your algorithm? On our level, that's not our focus, right? Our focus is that you have to come up with one algorithm, right? It's not where we are focusing on you have to come up with the optimal algorithm or almost optimal algorithm. So essentially, that's going to be next level. If you go to higher level classes, then that becomes important aspect. So not only you come out with algorithm, but they also come out with pretty optimized algorithm. All right, feasibility of testing through code. Basically, you say, oh, let's try out all the possible paths in our code. You may say, oh, well, that's not too bad, right? So that should be fairly easy. My program is not that big. I should be able to enumerate all the possible paths, right? So essentially, if you look at a program like this, if you have loops, if you have a big if statement or your switches, I mean, you quickly get into something called state space closure. Basically, the number of paths you have in your system will become exponential pretty quickly, right? So essentially, the state space is way too big for you to enumerate all the possible paths. So that's practically infeasible, right? So this is flowchart, and this flowchart, if you look at all the possible paths, you actually have 10 to the power of 12, which is already a fairly big number. You're not going to waste all your time on that, right? Because it's just practically infeasible to do. This is look at a flowchart which is very small, right? This is a very small flowchart, right? You have all drawn flowchart in your homework. You know that. So essentially, I mean, drawing flowchart is pretty glorious. I mean, it's writing code to basically to realize that flowchart sometimes is very easy, right? So one thing that we typically underestimate is how expressive our programming language is, right? Our programming language is actually very expressive. You can create program with massive number of paths. You have to test with a stroke of pen easily, right? Very easy in programming language. You can come up with a huge program, okay? So basically render your testing process really hard. So two things. If you test against specification, the input and output combination will probably ruin your life. If you test to code, the complexity of flowchart in terms of the paths through that flowchart will probably ruin your life too, right? So basically render, I mean, if you literally, explicitly, and just trivially, brute forcefully doing your test according to specification or code, okay, you're probably going to waste all your time, okay, and still not doing the job. And also another thing is testing to code is not reliable. I mean, you can only test a path when it exists, but you're not going to, if you literally say, I'm going to test all the paths I can find in the program, what happened to those paths you actually forgot about? Right? You made a mistake, you actually omit a path in your program. Your test to program approach will not actually get you that, that path. Actually, your test suite specification should be able to find that path for you. Okay? So it has to be a combination. All right. So essentially, access all the paths is not reliable. I mean, so access all the input, the combinations are not reliable either. Okay. So let's look at black box unit testing. Basically, say how you select your inputs. Okay. So now neither exhaustive testing to specification or code, neither is feasible. So how do we do? So our testing process, actually, you can see that this is the art, not really science yet in terms of use. Basically, whenever we need people like you to select, it's not a science, not an engineering approach in that sense. It's really that we need to leverage your wisdom to actually pick the right ones. So your goal is to select a small and manageable set of test cases to maximize the chance of detecting a fault or minimize the chance of wasting a test case. So so the best case would be every test case must detect a previously undetected fault, which is the goal, but typically you will not get there. Okay? So another thing that we need to consider is practically, you don't have enough time. You don't have enough time. So pretty much, what we do is we come up with test selection strategies, and we look at how much time we have available for testing. Then we basically come up with a prioritized list and say, hey, given the amount of time we have, we're going to run down from highest priority test down to lowest priority test. Basically, whenever somebody says, that's it, that's all the time you have, then we're done. Okay? Practical testing is just like our exam. Okay? Very much like our in-class exam. You come into our in-class exam, you come up with answers, you basically are trying to maximize your score, right? So minimize your effort on each problem so that you can finish. Some people really got it right, and they finish within the amount of time, then they get out, right? In that case, they actually basically select a small set of manageable test cases, they're done, they're out, right? I mean, for quite some of us, we stay there for the whole time, right? Still cannot figure out all the questions or things like that. Basically, well, if we give us more time, we may be able to actually get some more improvement, but hey, time's up. Practical software development, same deal. You always have a deadline to deliver your product. Okay? That trumps everything. Because if you're late, the chance your project will fail will increase dramatically. Okay? So that time to market is actually critical. In that case, you basically have to prioritize what set of tests you run first. So essentially, we need an approach that highlights as many faults as possible. We can use both test to specification or test to code, within given amount of time. Okay, with your time budget. So you will never have enough time to test in practical software development. You always have to cut your test short. Okay, unless you're really in Mars rover or something like that. But you know that even for systems like Boeing 737, they don't have enough time to test, right? Because they are in the competition economy. All right. So in terms of testing to specification, this is something you've got to know. Okay, called the equivalent testing or boundary value analysis, which you are already doing. But now you need to clarify that's what you're doing and keep doing it in a more consistent way. Okay? So essentially, here is the example. The specification of a database. Say that the product must handle any number of records between 1 and this large number. If the system can handle 34 records and this number of records, they probably can do something in the middle, and so forth. The idea is, how can you separate all the possible inputs into different buckets and only test one representative in that bucket. Okay? That's something you guys have been doing, I think, ever since you start programming in COLOS 160, 162. Okay? Basically, you first try something in the range. You say, oh, great, in the range, seems like correctly. Well, if I try something in a different range, outside range, or above lower bound or below lower bound above the maximum, then we'll see how that happens, right? So any one member of equivalent class is as good a test case. So in this case, this range have, okay, you have less than one record. That's an abnormal situation. You have more than the maximum record. That's an abnormal situation. Or you have exactly, in between this, in between the maximum and minimum, right? So these are the equivalent classes. All right. So essentially, you are actually doing boundary analysis once you have the equivalent classes, right? You need to basically test outside the boundary, right inside the boundary, on the boundary, and in the middle range. Okay? So this is a very simple way for you to systematically say, if I have input, how do I decide what to test? Okay? This is a fundamental approach, very simple, everybody can do, or everybody already is probably doing it, but you need to basically articulate and say, this is the way you start with if you have inputs and outputs. You select test case on or just to one side of the boundary of equivalent class. This actually it's been showing very effective in detecting faults, your corner cases. Okay? On the boundary, right inside, right outside, great test cases for your boundaries. In the middle, you're just trying to see if it's consistent. All right, so essentially, that's how you enumerate your test cases. You have 0 record, you have 1 record, you have 2 record, middle range. Right inside the boundary, on the boundary, right outside the boundary. Okay, so for this particular input variable, if you have all these things tested, you're probably safe. Okay, I can't say you're 100% safe because testing will never give you the perfect guarantee. But then if you try these, this is first, I would say 7 test cases you should try on this input variable. The goal is you don't try 16,000, more than 16,000 test cases, you try 7. Would this give you a 100% guarantee? No. Would you, so if somebody actually embed a Trojan, which only happen when you hit that 8,000, would that be possible? Yeah, practically it's possible. But I don't know. There's no way for me to know 8,000 is the magic number, right? So essentially, you're giving this range to prioritize. If you only have the time to run 7 test cases, this is probably going to be your best bet. Then you can use other techniques if you still have time to try if you can fish out that's interesting situation. But actually, in that case, testing to code is a better way to go to actually complement your input, right? When you look at what code you have in there, what branches you have in there, and then you can say, okay, I'm going to add those test cases. But if you have no knowledge about the inside working of the program, if you have this large number of test cases, more than 16,000, the first 7 you should try is right here. Okay? It's a simple way to decide what you need to try first. Similarly, you have output. So basically, you have to come up with test cases which will trigger the boundary cases of the output. Right? Input is easy, you just choose those boundary cases. Output is a little bit harder and say, can you actually come up with test cases that will trigger all the boundary conditions? Typically, your answer is you can only trigger boundary conditions on the boundary, inside the boundary, up to the boundary, upper boundary, and on the upper boundary. If you are able to come up with test cases which actually put you outside the boundary, you know you find the bug. That's how you find the bug. Okay? You find the behavior that's outside the bug, outside the range. Okay, so if you have simple inputs, if your program has simple inputs, equivalent class analysis, boundary analysis would be a default approach to go. However, if you have 1,000 input, 2,000 output, this approach is not scalable. Okay? Because you have to look at the combinations. I mean, the 1,000 input typically have correlations. Okay? So if you just pick on the boundary conditions, the test case you synthesize may not even be a valid test case. Okay? Because you have correlations among your input. You need in that case, you probably have to go to your specification, which we typically refer to as use cases, to come up with the data, test data, which have a strong correlation to real data. Okay. All right. Functional testing, that is about what we're going to talk about. Essentially, you're testing the functionality of the code by going from your requirements. In our class, your requirement would be your use cases and your scenario. What corresponding to those test cases? Your scenarios. How to represent your scenarios? Your sequence diagram and collaboration diagram. Okay? Why did you need those things? First, to guide your design process, and then also come back here. You use your use cases, your scenarios, your sequence diagram and collaboration diagram to drive your functional testing process. That is going to be your testing process with a chat app.